Welcome to The Explainer. You know, we live in a world that's just overflowing with data, but how do we find the real story? Today, we're going to unlock a really powerful technique that does exactly that. It finds the meaningful signal hidden in all the noise.
We are practically drowning in data. From the constant flicker of a stock price to the firing of a single neuron inside our own brains, information is being generated at a scale that's, well, it's just impossible for us to process on our own.
Just think about it for a second. Neuroscientists are trying to track thousands of neurons all firing at once. Financial analysts are watching hundreds of stocks that are all interconnected. A single image you take is a grid of millions of pixels. It's what we call a high-dimensional mess, and trying to make sense of it can seem completely impossible. So that's the big question, right? This is the core challenge for scientists and analysts everywhere. We have this gut feeling that there are simpler patterns hidden inside all that chaos. But how in the world do you tune out all the static to actually hear the music?
Well, the answer is a surprisingly elegant technique called principal component analysis, or as you'll usually hear it, PCA. It's a foundational tool that lets us cut right through all that static and find what really matters.
So at its heart, PCA is a method for dimension reduction. Now that's just a fancy way of saying it creates a simple summary of a really complex data set. It takes this huge number of variables that are all tangled up together and transforms them into just a few new variables that are completely independent. And that's the key, you know? It untangles the mess so we can see the core drivers of what's going on separately.
Okay, to really get a feel for how PCA works, let's not worry about the math just yet. Instead, let's think about perspective. Imagine your data isn't a spreadsheet, but a cloud of points just floating in space. From one angle, it just looks like a shapeless blob, right? But what if you could rotate it? Suddenly, you find the perfect perspective, the one where the cloud stretches out the most, revealing its true shape. That direction of maximum stretch, that is your first principal component. It's the most important piece of the story. Then, PCA finds the next best angle, one that's totally independent of the first, and then the next. It's just a systematic way of finding the most interesting views of your data. So what are these new, more informative directions that PCA finds? They have some specific mathematical names, but trust me, the concepts themselves are actually very intuitive.
These new axes are called eigenvectors. You can just think of them as the fundamental patterns or themes hidden in your data. In our cloud metaphor, the first eigenvector is simply that main direction of maximum spread we found. It's the most important viewpoint, period.
But how does PCA know which direction is most important? Well, that's where eigenvalues come in. An eigenvalue is basically an importance score for its partner eigenvector. The bigger the eigenvalue, the more of the data's story that direction tells. It's how we can rank all the components from most significant to least.
And this is where it gets really, really powerful. Just look at this. The first principal component, PC1, captures a massive 80% of all the variation in the data. 80%! Add in the second one, PC2, and together they explain 95% of the entire story. Everything else in that little others bar, we can often just treat it as noise and safely ignore it. This just shows you the incredible transformation that happens. We go from a high-dimensional mess with hundreds of tangled variables to a clean, manageable summary of just a few key components. We're moving from a world where the signal is totally hidden by noise to one where the essential patterns are just revealed. Okay, so this all sounds great in theory, but where does PCA actually make a difference? Let's take a look at how this tool is driving some incredible discoveries out in the real world.
Let's start with finance. Imagine you're an analyst studying the S&P 500. You're looking at 500 different stocks, and so many of them move together in really complicated ways. Honestly, trying to model all of them at once is a recipe for disaster.
But by applying PCA, you can boil those 500 stocks down to just a handful of principal components. The first component, that might represent the overall market movement. A second one might capture the difference between, say, tech stocks and industrial stocks. All of a sudden, you've uncovered the main drivers of the market, and you can build much simpler, more robust financial models.
All right, now let's jump over to neuroscience. When researchers record thousands of neurons firing at the same time, the raw data looks like absolute, complete chaos.
But PCA can dig into that chaos and find these hidden, simpler trajectories. You can think of these as the main highways of neural activity that run through the brain. These core patterns are what actually correspond to our thoughts and our perceptions.
It allows scientists to finally separate the true signal of cognition from all that background noise.
And what about images? A single photo of a face contains millions of data points, one for every single pixel. How can a computer possibly learn to recognize a face from all of that information?
It turns out, PCA provides a pretty incredible solution. By analyzing thousands of photos, it doesn't learn individual faces. It learns the fundamental building blocks of all faces. These are what we call eigenfaces. They look like these ghostly images that represent features like noseness or eyebrow shape. So any real face can be described as a simple recipe, just a unique mix of these core components. And that is how facial recognition systems work so efficiently.
So here's the crucial takeaway. Whether we're talking about stocks or neurons or faces, PCA is one of the most powerful first steps we can take to make sense of our data-rich world. It is a fantastic method for finding that hidden structure and finally hearing the main story that the data is trying to tell us. By finding the essential signal in the noise, PCA opens up this whole new world of understanding. And it really makes you wonder, doesn't it? What other profound secrets about our world are just hiding in plain sight, waiting in the data for us to find the right way to look?